Hey guys, welcome back. It's Mr. Alting here helping you with another problem. This one taken right from your textbook. It's about uniform motion, the ones where we make the tables. This is right from the pages I asked you to study for the test tomorrow on Friday. This is from page 179. I think in the textbook is problem 16. Here's what it has to say. It says, Lori left home and ran to the lake at 10 miles per hour. She ran back home at 8 miles per hour. The entire trip took 27 minutes. How far did she run in all? Before we do anything, you guys got to remember we set all of these problems up the same way. We start by making a table. And you might think to yourself, what does my table look like? Well, you sort of frame it with the distance formula, which says rate times time multiplied by time is equal to distance, okay? And if you don't know that formula, that would be a really good idea just to put it in your brain and try to keep it there. You could even make up a silly analogy if you wanted to. Righteous tacos equals Doritos. I don't know. Something silly. Silly things are easy to remember. Now I'm making the table obviously with 2 rows. Why am I doing that? Because in all of these problems, we're going to be measuring the distance of 2 things and then comparing those things at the end of the problem. And we're going to look here in this problem, what are the 2 things that I'm comparing distance-wise? Well, she left home and went to the lake. That is one distance that we're going to be able to measure. And then if you look in just the very next sentence, it says she ran back home. So really, the trip there to the lake and the trip from the lake, those are the 2 distances we're measuring. And so I'm just going to label those over here, to lake, and then from the lake. You know, if you wanted to label it as from home to home, you can do that too, or a combination of these, no big deal. Now that I have this, I'm going to fill these in, and this is, you know, a part that some of you are getting stuck on, but don't let it fool you. It's not so bad. When I read this first sentence, it says that Lori ran to the lake at 10 miles per hour. What is miles per hour? Well, that's a rate. I'm talking about how far she went over some sort of time or interval. So that's a rate. We put that right there. Just 10. No need to include the units. And that's all we do. Now, how much time did it take? Well, I don't know. I know that the whole trip took 27 minutes, but do I know how long it took specifically to get to the lake? I don't. So I'm going to call that t. I could have called that x, no big deal. And before finding the distance, I'm going to move on to the next one. I'm going to find the distances at the same time. If we move on to the next sentence, it says that she ran back at 8 miles per hour. So again, that's a rate, so it goes right there. And this might be the trickiest part of this problem right here. I actually recorded this problem once and messed it up because I didn't notice something. We need to look at this 27 minutes and remember something. That over here with our rate, she was not running at 10 miles per minute, which would be insane, by the way. She's running at 10 miles per hour. And so I have to make sure that my units are in the same measurement, okay? A minute is not the same thing as an hour. So I have to change minutes to hours. And we're going to go ahead and just turn this into a fraction. I think that's probably going to be the easiest way to think about it. And how many hours is 27 minutes? Well, it's 27 out of 60 hours. Which, by the way, is just equal to 0.45. I like to use decimals personally. I'm not a big fractions guy. If you want to leave that as a fraction, you absolutely could. But this is the same thing as 0.45 hours. And so we're going to use this. And this is really the hardest part because you guys have been struggling with this concept that this is really 0.45 hours minus t. And let's just take a minute to talk about why this is. How did I get this? How did I know that? And to tell you how, I'm going to show you a little timeline. So right back here, maybe we have, I don't know, when the dinosaurs were born. And then maybe, I don't know, when Mr. Alting was born. and then all of the important events of world history since Mr. Elting's birth. And then we finally hit this, and this is when Lori, of course, left home. And at this time, this is 0 minutes, you know that. And by the end of her trip, she is gone. I'm just going to label this. She's traveled an entire arduous long journey of 27 minutes, okay? Now, that 27 minutes is broken up into two parts. The first part is, well, at a certain point, she made it to the lake, right? And a lot of you might be tempted to say, well, that's just half the time. And that's true normally, but notice here, she's running at different speeds to the lake and from the lake, which means it's not going to take the same amount of time to get there and to get back. So if I look here, it's not quite half the time, and that's what t is. And now I have some sort of, by the way, I don't know what t is, so I just sort of made a random time here. But what we have left over, this chunk right here, the rest of the 27 minutes, or the 0.45 hours, by the way, if that helps you, that's not 27, that's 0.45. Well, the rest of it is really just the whole thing minus the time that it took to get there. That's going to be the time that it took to get back, which if you write that algebraically, it's the entire amount of time, which is 0.45 hours, minus the amount of time that it took to get there, which is t, so 0.45 minus t. Now that I've done that, and if you have questions of that, we can talk about that a little more. Come in tomorrow and ask me about it. We're going to multiply this guy out, and this really isn't too bad if you remember how to do it. 10 times t is just 10t. That is the distance from her house to the lake. And now going back, we're going to do 8 times 0.45. If I were you, I would whip out a calculator to do that. But I end up getting 3.6. And then you have to remember something important here. I have to distribute this 8. And so this is 8 times negative t, or negative 8t minus at, if you prefer. And boom, we're done with the table. That's great. But we're not done yet. And you know this. We have to somehow look back at the original problem, now decide for ourselves, how do I use the table to answer the question? And the question was, how far did you run in all? And in all of these problems, you're going to have to solve for the variable. And the variable this time was t. In other problems, it might be the rate. It could even be the distance. But I am going to use these two distances, and I'm always going to use the distances that I get out and relate them to each other some way. And the way they're related in this problem is the fact that, well, if I go somewhere and I return from that same place and I took the same route, it's really the same distance. And so this problem is really more simple than it might seem, in that I can just set both of these distances equal to each other. By the way, that's a decimal, not a comma, so it's 3.6 minus 8t. And this is the equation, and I'm just going to solve this, so don't forget how to solve equations. It's not so bad. And let's just do it. I'm going to add 8t to both sides. As you guys know, it's going to give me 18t on this left side. Get 18t is equal to 3.6. I'm going to finish solving this problem by just dividing both sides by 18. And again, what's 3.6 divided by 18? Well, you can probably do that in your head. It's going to be 0.2. Notice that this is the same thing as 36. We're just going to have a decimal point. So the answer for t is 0.2. And you have to think to yourself, that's 0.2 hours. And we love thinking in minutes. So we could really translate this back 2 minutes. And by the way, that's going to be 20 minutes. Actually, that's not true. It's going to be some other amount of minutes. I'm not sure. But if you look at a problem, don't do anything with that yet. Look back. What is it asking me for? Because it actually tells us that we want to know how far. And you go back to your original formula. In the table, it says, well, this distance is 10t. And now that I know what t is, well, I can find that really easily. Let's just go ahead and do that together. What's 10 times 0.2? In other words, what is 1/5 of 10? And you guys know how to multiply by 10. You're just going to carry the decimal point over. You're going to get 2. So the answer here is 2 miles because our units were miles per hour. And you could plug in 0.2 over here and get the same exact thing. You're going to get 3.6 minus 1.6, which is also 2. And that is the answer. If you have any questions over this, please just rewatch the video, do yourself a favor, see if you can't follow the work and stay a step ahead of me. There are more problems in your textbooks over this if you need some practice. Email me or talk to me tomorrow in class if you have any more questions. Thanks, guys.